This is the Math 3 notes for Unit 3, Section 6. And today we're going to be talking about using division to help us factor. Before I get into this, I've got a question for you. Who invented algebra? And, well, if you don't know, it was a clever expert. Okay, with that said, we're going to take a look at division. Now, it does say long division and synthetic division. Actually, what I'm going to do here is just X out the long division. I'm only going to teach you something called synthetic division, okay, in this lesson. We may get back to the long division later, okay. So synthetic division is division, and but it's division with polynomials, and here's how we set it up. So let's look at this first one. We have x squared plus 6x minus 7. In front of the x squared there is a 1, and what we're going to grab are the coefficients of x squared, x, and then the constants. So we got 1x squared, we have a 6x, and we have a negative 7. So we just leave out the x squared, leave out the x. We're just writing those coefficients. And then we're dividing by x minus 1. In a similar way, when we had a factor and we changed it to an x-intercept, and so if we had the factor x minus 1, we'd get x equals 1. Do you guys remember that? So we're going to take that value and put it over here. So we're not using the minus 1, but we're using the x-intercept of that factor. Okay. So that's the setup. Once you set it up, there is a pattern that we follow, and the pattern is you start with this first number, and whatever that first number is, you drop it down. So you just copy that first number down. So there's a 1 there, so I put a 1 here. Okay. After that, you multiply those two numbers. So 1 times 1 is 1. And then whatever you get, you add it to this number. So 1 plus 1, sorry, 1 times 1 plus 6 is what you're doing in your head. And you get 7, and you put the answer here. Right beneath it, 6. And then we're going to do this process again. Now we take the 1 here, multiply it with the 7, and add it to this last negative 7. So again, in your head, you're doing 1 times 7 plus negative 7. And 1 times 7 is 7, plus negative 7 is 0, so we get 0. Okay. That's the algorithm. Now, once you get that far, usually I separate that last number from the other two. I put a little line here, because what happens is this is the remainder. This is your constant term. That means without the x. This is your x term. And then if we had another one, it would be your x squared term, and so on. And so that 1, 7 represents 1x plus 7. Okay. That 1 right here represents the factor. Remember, that represents your x minus 1. And so what we've done is we've factored. We originally had the x squared plus 6x minus 7. and we factored it to x minus 1 and x plus 7. You may be thinking, okay, this is we could have factored that a whole different way, right? And that's true. But this using synthetic division can come in handy with more complicated factoring problems. Here we just wanted to start with a simple one to show you how it works. So let's try that process again. Well, actually, let's answer this. So it's asking, is x minus 1 a factor of x squared plus 6x minus 7? And what you need to know is a number is a factor if when you divide by it, you get a remainder of 0. For example, we know that 4 is a factor of 8 because when we divide 8 by 4, we get 2 and the remainder 0. But 5 is not a factor of 8 because when we divide here, we get a remainder of 3. So if your remainder is not 0, what you're dividing by is not a factor. But if your remainder is 0, then it is a factor. And in this problem, we divided x squared plus 6x minus 7 by x minus 1, and our remainder is 0. So we're going to say yes, because our remainder equals 0. Okay, so let's try this process again. X to the 4th plus 3x cubed plus 6x minus 2 divided by x plus 2. Notice we're missing an x squared. Okay, and if you're missing anything in between, I need you to rewrite this. So this is x to the 4th plus 3x to the 3rd. There's no x squared, so I'm going to put plus 0x squared plus 6x minus 2. And that's still, we're dividing by x plus 2. So setting up our synthetic division table, we have 1x to the 4th, 3x to the 3rd, 0x squared, 6x minus 2. Okay, so those numbers again are coming from, there's an invisible 1 here, there's your 3, 0, 6, negative 2. Okay, those are the coefficients. Once you grab those, then we're going to look at what we're dividing by. We're dividing by x plus 2. Think, well, how if x plus 2 was a factor, what would the x-intercept be? Negative 2, that kind of thinking. And so we're going to use negative 2 over here. Our process, whatever that first number is, we drop straight down. And then take negative 2 times 1 and add it to 3. Well, negative 2 times 1 is negative 2 plus 3 gives you 1. And you put your answer here. Repeat that. Negative 2 times 1 plus 0. Negative 2 times 1 plus 0 is negative 2. Do this again. Negative 2 times negative 2 plus 6. Negative 2 times negative 2 is positive 4, plus 6 gives you 10. One more time. negative 2 times 10 plus negative 2 gives you negative 20 minus 2, which is negative 22. Remember that last number, that negative 22 that we got, or whatever the last number is, that's your remainder. Ten is your constant. That means no x. This is your x term. This is your x squared term. This is your x to the third term. So what happened here is we divided and we ended up with 1x to the third plus 1x squared minus 2x plus 10 with a remainder of negative 22. Now there's a couple different ways we can handle remainders. For right now, we're just going to put r for remainder negative 22. Okay. So because our remainder is not 0, this is not a factor, and so we would x plus 2 is not a factor, and this definitely is not a factor, and so is our question here is going to be, is x plus 2 a factor of x to the fourth plus 3x cubed plus 6x minus 2? Our answer is going to be no, because our remainder does not equal 0. So we're going to be most interested when our remainder is 0, but it is important to know, okay, if you have a remainder of 0, you're looking at a factor. If it's not 0, then it's not a factor. So our goal now is to factor completely. Last time we were together, we looked at factoring 4 terms by grouping, and if you try that, sometimes that works, sometimes that doesn't work. Don't write this down, but let me show you that factoring by grouping won't work here. So here I have 4 terms. The left 2 terms I could factor out an x squared. The right 2 terms can't factor out anything. So I'll factor out a negative 1. And you can already see here, factoring by grouping is not going to work because what we have in the parentheses don't match. Right here we have an x minus 1, here we have a 17x plus 5. Nothing's going to work here for us. So we definitely need a different method for factoring here. What they are telling us here is that x minus 5 is a factor. So f of x is equal to x minus 5 times something. Okay, and so we got to figure out, well, what is that something? Well, if I tell you I want you to factor the number 220, and I tell you that that's equal to 10 times something, how are you going to find that missing piece? You're going to divide 220 by 10, get 22, and you got your answer. Same idea here. We know that x cubed minus x squared minus 17x minus 15 is x minus 5 times something. So I'm going to divide by x minus 5 and find out what I get. We're going to use synthetic division. So remember, we set it up. There's 1x cubed. There's negative 1x squared. So I'm going to go 1x cubed, negative 1 for x squared, negative 17 for x, negative 15 for the constant. I'm dividing by x minus 5, so use the x-intercept, which would be x equals 5, right? So put the 5 here. Take down the 1. And then start your process here where you're going to go 5 times 1 plus negative 1. Five times 1 plus negative 1 is 5 minus 1, which is 4. On to the next part. Five times 4 minus 17. Well, 5 times 4 is 20. 20 minus 17 is 3. And last time here, 5 times 3 plus negative 15. Which is 0. And that's what we want, because remember, if x minus 5 is a factor and we divide by a factor, our remainder needs to be 0. Okay? So 0 is our remainder. Three is our constant term. 4 is our x term. 1 is our x squared term. So that is the missing piece, and we can write that in. So we have 1x squared. We have 4x. And we have plus 3. And we factored. Okay. Let me move this down a little bit out of our way. So if we can factor more, we need to factor more. And so what I'm going to do is I'm going to look at the x squared plus 4x plus 3 and see, is there anything else we can do to that? Can we come up with two numbers that multiply to 3 and add to 4? And as you're thinking about it, you should come up with 3 and 1. So we can factor even further. We have the x minus 5, leave that there. And then this second part can factor to x plus 3 and x plus 1. And now it's fully factored. So here we could see that synthetic division helped us get to the factoring. Yeah, it's a little bit complicated, but it worked. So we're going to practice that again. So here on this next one, they're asking us, or they're telling us, that x plus 3 is a factor. And so we got to find out what x plus 3 times what gives us the original problem. Set up a synthetic division table. We got 1x to the third, right? We have a negative 1x squared. We have a negative 8x and a positive 12. I don't have to put the plus sign though. We're dividing by x plus 3, so we think, well, what would that x-intercept be? It would be negative 3. Use the x-intercept here. We bring that first number straight down, whatever's there. Then we multiply negative 3 times 1, and then add it with the negative 1 here. So negative 3 times 1 plus negative 1 comes out to be negative 4. And then negative 3 times negative 4 plus negative 8, and I don't know why I put the x there, I apologize. Erase that x. Shouldn't have any x's on this. So negative 3 times negative 4 plus negative 8. That's going to give you 12 plus negative 8, which is 4. And negative 3 times 4 plus 12. So negative 3, times 4 plus 12, that's going to give you 0. And that's what we want. Again, if you divide by a factor, you need to have a remainder of 0. So 0 is our remainder, 4 is the constant, negative 4 is your x term, 1 is your x squared term, and so we have 1x squared minus 4x plus 4. I'm going to move this over to the right hand side, out of the way, and see if we can factor even further. This x squared minus 4x plus 4, can we find two numbers that multiply to 4 and add to negative 4? And you should get negative 2 and negative 2. So it does factor further. So bring down the x plus 3 and factor to x minus 2 times x minus 2. And because we have repeating factors, we could even condense this further to x plus 3 times x minus 2 squared. So our next one, we're given 1, 0. We want to factor and sketch the polynomial function. This is different than the last couple problems, because in the last problem we're giving a factor, not a 0. And remember what the word what a 0 is. A 0 is, as long as we're talking about a real number, and we're talking about 3, a 0 is a root. 0 is also an x-intercept if we're talking about real numbers. Okay, so it's saying that 3 is our x-intercept, or one of the x-intercepts, which means that x minus 3 is our factor. Okay. So when we're factoring this, we know, okay, this is equal to x minus 3 times something. And like we did in the previous two examples, we can use synthetic division. So set up a synthetic division table. We have 2x to the third, 5x squared, negative 28x, negative 15. Those are the coefficients. X minus 3 is what we want to divide it by, but we're going to use the x-intercept, which is 3. And in the process, bring down the 2. And then we're going to multiply 3 times 2 and add it to the 5. 3 times 2 is 6, plus 5 is 11. Put the answer here right beneath the 5. And then we're going to multiply 3 times 11. And then add negative 28. So 3 times 11 is 33, plus negative 28 is 5. I'm going to write the 5 below the negative 28. And then 3 times 5 plus negative 15. 3 times 5 is 15, plus negative 15 gives us 0, and that's what we want because we're dividing by a factor. And whenever you divide by a factor, you need a remainder of 0. So it's a good check to make sure you're doing this process right. So the 0 is our remainder. 5's our constant. 11 is our x term. 2 is our x squared term. And so we get 2x squared plus 11x plus 5. I'm just going to move this over a little bit. So now we're going to try to factor further. We have a trinomial. We're going to think of what two numbers multiply to 2 times 5. So we want to multiply to 10 and add to 11. So what are they? You should get 10 and 1. Because there's a 2 in front of the x squared, can't use the shortcut here. So bring down the x minus 3, don't forget that. And we're going to split up our 2x squared plus 11x plus 5 into 4 terms. We get 2x squared plus 10x plus 1x plus 5. And then we look at the left two terms. We can factor a 2x out. And we're left with x plus 5. Look at the right two terms. You could factor 1 out. We're left with x plus 5. Going to put everything in brackets, and don't forget to bring down the x minus 3. And we have 2x plus 5. Factor that out. You get x plus 5 times 2x plus 1, and bring down your x minus 3. And now it is fully factored. The factors will give you your x-intercepts. The first factor, x minus 3, gives us x equals 3, because if you plug in 3 for x, you get 0. The second x-intercept is going to be negative 5. But the third one may not be so obvious to you. To find this, you can just take the 2x plus 1, set it equal to 0, and solve. Subtract 1. Divide by 2. So you get negative 1/2. So those are our 3 x-intercepts. Let's find the end behavior. When I find the end behavior, I'm going to go and look at the original problem. It's easier to see what the degree is and what the leading coefficient is when you're looking at the original problem than in the factored form. So we see that the degree is 3, that's your highest power, and that's an odd number. And the leading coefficient we see is positive 2, which is positive. And so because the leading coefficient is positive, we know the right end's pointed up, Because the degree is odd, we know the left end is pointed in the opposite direction. Lastly, we need our y-intercept. Our y-intercept comes from plugging in 0 for x. I'll use the factored form. So we end up with y is 0 minus 3 times 0 plus 5 times 2 times 0 plus 1. So that's negative 3 times 5 times 1, which is negative 15. Let's put all that together in our graph. So we have x-intercepts at 3, negative 5, and negative 1/2. Negative 1/2 is between 0 and negative 1. We have a y-intercept at negative 15. And we have the left side pointed down. All our x-intercepts, there's no repeats. So when we're going to pass through all of our points. So when you pass through that 1/2, you're going to dip down to negative 15 and then back up, and we have our graph. Okay, our last problem here. I'm going to do this one in a different order. First, I'm going to get the end behavior. So we see the degree is 3. The leading coefficient is 1. Positive leading coefficient, which tells us the right side points up. Odd degree, which tells us the left side points down. So that's our end behavior. I'm going to move that down by the graph and save it for later. Okay. Next, I want to get my x-intercept, or I want to factor this thing in order to get my x-intercepts, right? And so they tell us one of the x-intercepts is negative 5. Which means a factor is x plus 5. And so we know this is equal to x plus 5 times something. To find the missing something, we're going to use synthetic division. We have 1x to the third, 9x squared, 24x, and 20. We're dividing by x plus 5. The x-intercept is negative 5, so we put the negative 5 here. And then go through the process. Our first step is to take that 1, drop it down. Then we're going to multiply negative 5 times that 1 that disappeared. And then add it with the 9. So negative 5 times 1 plus 9 is 4. And you write that right below the 9. Next, we're going to multiply the negative 5 with the 4 and add it to 24. So negative 5 times 4 is negative 20 plus 24. So negative 20 plus 24 is 4. Write that beneath the 24. And then we're hoping that we get 0 for our last number because the last number represents the remainder, and if you're dividing by a factor, your remainder should be 0. So negative 5 times 4 is positive. Negative 20 plus 20 is going to give us that 0. So now everything is in place. 0 is our remainder. 4 is the constant. This 4 is the x value, and this goes with the x squared. So this is 1x squared plus 4x plus 4. So to factor further, we're looking for two numbers that multiply to 4 and add to 4. So 2 and 2. We can take the shortcut because there's a 1 in front of the x squared. So x plus 5 we already had, and then this is going to factor to x plus 2 times x plus 2. So now we can write our x-intercepts. They are x equals negative 5, x equals negative 2, x equals negative 2. Notice that we have double the negative 2, so we say the multiplicity is 2 here, which is telling us it's going to bounce at negative 2. Okay, lastly we want our y-intercept. We get our y-intercept by plugging in 0 for x. So y is 0 plus 5 times 0 plus 2 times 0 plus 2, or 5 times 2 times 2, which is 20. Alright, so now let's put our pieces together. And put this graph together. So we have x-intercept at negative 5, 1, 2, 3, 4, 5 to the left, and at negative 2. A y-intercept at positive 20. Left side points down. We're going to pass through the negative 5. We're going to bounce at negative 2 and then come back up through the 20, and there is our graph. So here we used synthetic division to help us factor so that we can graph. Have a great day.